We've all been there, right? You're staring at your screen, completely stuck, just guessing your way through a bug. Well, in this explainer, we're going to unpack the systematic framework that top-tier developers use to find and fix bugs 10 times faster. It's time to stop guessing and start solving. Okay, so picture this. 8 hours. That's how long a developer recently spent hunting down one single incredibly frustrating bug. I mean, that's an entire workday, just gone, wasted on one problem, just spinning your wheels in that cycle of trial, error, and mounting frustration. But now, what if I told you that same bug could have been squashed in just 47 minutes? That's the power we're talking about. It's the difference between blindly searching in a haystack and having a GPS that takes you right to the spot. This isn't about being some kind of coding wizard. It's about having a way smarter process. And here's the crucial point, really. The bug itself is rarely the biggest time suck. The real culprit is the inefficient, unstructured way we go about finding it. You see, elite developers don't just guess better. They have a powerful toolkit of systematic techniques they pull out every single time. So, the first step in any good bug hunt is to isolate the failure. You gotta find where the thing actually lives. We're gonna start with 2 techniques that can shrink your search area exponentially, helping you pinpoint the exact location of the problem. So let's say you're faced with this classic scenario. A bug is hiding somewhere in a massive 2,000-line file. The natural impulse is to just start reading from the top, right? But trust me, that is the slow path. There's a much more logical way to tackle this. Instead of reading every line, you can apply the logic of a binary search algorithm directly to your code. This whole method is about efficiently eliminating possibilities. You're not just searching anymore, you're systematically dividing and conquering the problem. And the power of this process is just its raw speed. You comment out half the code, run your test. If it still fails, you know the bug's in the code you kept. If it passes, well, the bug is in the code you just commented out. By doing this just a few times, you can shrink a 2,000-line problem down to just 50 lines in maybe 5 or 6 steps. It's incredible. Now, that's great for finding a bug in a static block of code, but what about regressions? You know, those sneaky bugs where you swear, this works last week. For these, there's an even more powerful automated tool that actually uses your code's own history to find the culprit. Let me introduce you to Git Bisect. This is pretty much the nuclear option for finding the exact moment a bug was born. You just tell Git a commit where things were working and the current broken one. It then does all the heavy lifting, using a binary search on your commit history and checking out a commit right in the middle for you to test. Your job is super simple. You just test that commit and mark it good or bad. Git then automatically repeats the search, narrowing the range of commits every single time. Even if you have hundreds of commits to search through, this process can find the single culprit in just 5 to 7 steps. It is an absolute game changer for tracking down regressions. Okay, so you've found the bug's location. That is half the battle for sure. But now we need to understand why it's happening, because that's the key to a robust fix. And this requires a mental shift, from just doing things to actually thinking through the problem. So on the one hand, you have the common approach, guesswork. It's a whole lot of, let me try this, and what if I just change that? But on the other hand, you have the system that elite developers use, which is really just the scientific method applied to code. It replaces all those random actions with a structured investigation. This disciplined process basically turns debugging into a science. So, for example, instead of adding random print statements everywhere, you'd observe a crash, and then you'd hypothesize. I bet this only happens for customers with no address. Your prediction, then, is that checking the database will prove it. You test that one specific thing, and boom, you've confirmed the cause and can write a targeted fix. All right, now for a technique that might sound a little strange, but I promise you, it's incredibly effective and it's backed by cognitive science. It leverages the simple act of speaking to unlock solutions your brain already knows, but just hasn't brought to the surface yet. It's called rubber duck debugging, and the idea is simple. You grab an inanimate object, a rubber duck is traditional, but hey, a coffee mug works too, and you explain your code to it line by line, out loud. Just forcing yourself to verbalize the logic makes you confront your own assumptions step by step. And this is a perfect illustration of its power. A developer was stuck for 45 minutes just staring at the code. Finally, they started explaining it to a colleague, and mid-sentence, they realized they were checking for the status open instead of released. They'd read that line dozens of times, but the second they said it out loud, the obvious flaw just jumped right out at them. So we have techniques to find the location and techniques to understand the cause. But the real path to mastery isn't just using one of these in isolation. It's knowing how to combine them into a single, powerful workflow. So think of this as your master plan. You start broad with a binary search to narrow the scope, then you apply the scientific method to form a solid hypothesis. If you know it's a recent bug, you can deploy Git Bisect to find the exact cause. And if you're ever truly stuck, the rubber duck is always there to help you reset your thinking. Ultimately, this isn't just about fixing bugs faster. When you trade that frustrating guesswork for a systematic toolkit, the real question is, what are you going to do with all that time you get back? This is about reclaiming your focus, your energy, and yeah, your most valuable resource of all.